do not have giant budgets. And basically, I do a lot of this through strategic partners, and one's manufacturing. That's Whiten. I've been with since 2001, working with them as a, and we, like I said, we deal with custom machinists. I do, and Whiten, the same guy, working through there so you can get stuff built for prototypes. I have basically been working with injection molding fabricators and mold designers, because eventually you have a special product, you put it in something, and you're gonna use probably plastic or something, or they can also do machine metal, but no one does anymore. It's just plastic and injection molding on there. And when you do with the mold designers, you actually, nowadays it's brand new, if it isn't too big and too expensive, you print it. Okay, you're getting your thing out and it's a printed form before you go to the injection mold route, because that's pretty expensive, and I can explain that later. So that's like a modern thing when you're prototyping, is you actually have a computer-aided designer. Basically, the mold designer does also, if you get a good one, he can make an output format that's compatible with both products, and that's pretty important to do. Okay, it's compatible with a 3D printer, which isn't always the case, and injection molder, that you can make a mold that works. So it's pretty important to get the right guy. And I work with printed circuit board fabricators. I use one in Colorado because it's just the quickest and easiest, and I get really good responses from local things. It's in Aurora. It's you can't tell you how much that saves in time and hassle. I work with the same people very quickly. And packaging, same thing. I have some guys I'm already talking to that basically out of Denver. I don't really go very far unless I have to, because that really slows things down. If you want to do a project, you bog down immediately if you have a long distance between you. Although I just said that, the only really good mold designers and injection molding fabricators are mostly in the Midwest, and, Minnesota and Wisconsin. So I just violated the rule. They just do it there. And it's really a hotbed of that. So when you have to do it, you do it. And I have guys I work with that do smartphone application programming. It's all the rage until people see the cost of actually getting the application done. And basically, I also work with a guy I've worked with for years at Navitech, and actually at the radar thing, for what I call large system software programming. I do all the small system programming stuff like that, but there are giant systems, and I'll show you one where you have a real, what I call a system software programmer. It's totally different than, I'm at more of a device driver level for smaller projects and other things level. And when you build many, I guess there's many computing elements or processors, and many different processes and things, you interconnect them, you just go to a different type of guy who sets these giant systems up. And that's the people I've worked with. All right, and this is products I worked on at Hewlett Packard. They were just, it was in the sources and analyzers. The top two were signal sources, and the bottom is a spectrum analyzer, digital spectrum analyzer, and that was, these are still for sale. I just pulled these off the internet like a week ago, and these are used instruments for sale. They basically work forever and last forever, apparently, and I was working on those in one of them 1979. So they've held their value somehow.
Some of this equipment just move into the cloud, like I would send my my inputs for the spectrum analyzer to some site, and it would give me, the same output as that.
Sort of, but the biggest thing these have is the front end that massage the electrical signal to it. You're right, once you digitize the data.
It's got to be analog, right?
There's an analog thing, and how accurate you can basically digitize a signal, that's the hard part, and that's why these have value. You still can't do the kind of stuff in a different way. And that's why they have a lot of value. Say, well, you need this kind of accuracy, you need these kind of things. In fact, with the cloud and digital computing, instrumentation has gotten cheaper and worse in performance. So I say, okay, but people really didn't need that. So if you're actually doing instrumentation, you say, okay, if we have a low budget and we don't need high performance equipment, we don't buy this anymore, but they still buy this stuff off the web when they need high performance. You just cannot buy it. You can't buy that capability off the web or with a digitizing machine that you get today. It just, the market niche is too small for people to attack, and it's already been done. So it's just how it is. That stuff still is for sale forever for a reason. And I worked at GT Government Systems in Raytheon on the Altair radar. This is like probably the longest distance radar there is on the planet that moves. It actually tracked Voyager when it went out of the solar system. No other radar can track things that far. It's not even remotely part of their capabilities. It's actually really a gigantic dish, 150 feet in diameter. And one of the things you can't see that I did, I used to work on the waveguide antenna feeds. You can see them up there, and it was actually a pretty dangerous job to work on them if they're broken and fix them. And actually, when they did upgrades to be up there with, you know, the mechanics and stuff, and making sure they installed it right and testing everything up there that high. This is on a remote atoll in the Pacific, and you don't realize that's aluminum, and it's covered with like salt spray all the time. It's really slippery, really dangerous. That was just the outside job. It was actually more fun because I was away from management, and no manager would go up there. Okay, and ESPN Sports, I just was basically doing communications of sending TV signals and actually radio communications. They have a giant network of everybody who's in with a hierarchy of who's allowed to talk to who. And the biggest level guy can talk to everybody, and they shut everybody off. And it's pretty complicated. The number of people they have for one of these events is gigantic. And each one of them has a radio they talk to at all times. And anyways, it was just a fun job, and I used to do. And this is when I wanted to start with, I guess, which is the product line. I worked for Navitec. It was an entire product line in evolutionary design. And the boats it was used on, these are what you call lifting body, not actually foils, actually lift the boat out of the water to a certain height. It's different from hydrofoils, which have a problem. They get up to the surface of the water and then they're hitting waves. So that lifting thing is just under the surface always and controlled very carefully. So it runs smoothly as opposed to banging across the water. Hydrofoils don't work. And anyone, except on lakes, you'll see them in superboat races. They do not work in the ocean. So this is a technology, it was for the Office of Naval Research, and that's basically a 100-foot boat there. And what you don't recognize is they have like 4 1,000 horsepower motors on them driving that thing. And it had, I wish I had the picture, it has a rooster tail that was literally a quarter of a mile long when it was fired up from there. They have surface, what they call surface cutting props. And it's really cool to ride in it, and we're riding it by Waikiki Beach with a quarter-mile rooster tail at like 70 miles an hour, which is really cool to impress the people. You're not that far off the shore.
So you raise it up to reduce the frictional drag of the hull?
That's exactly right. In fact, but it's really dangerous to get air, so the thing that you like to do is raise up to just right there. As soon as you get up in the air, you can actually fall down and you can flip over and kill everyone. Because these that boat weighs many, many tons, and it'll kill everyone when it flips over at that speed in the wheelhouse. So that's a big deal with these boats, is system redundancy. And the other ones that aren't, they're single system. You see, they call it SLED 36. They have a little wing under there, and that's one of the things I worked on that just controls those things, and it lifts it from the back. And basically does this similar thing. It just keeps it a ride control system, so sort of like keeps you from bashing through waves. It basically reduces the bashing tremendously. And this is dual system, this Blade Runner 51, and it was actually a boat that was it may have just been broken, but a few years ago it was the fastest boat. They do a round England race and for the time, and it just kills the average cigarette boats. They cannot, in an open ocean, go as fast as that can go because of it. It just they can't survive with bouncing. Actually, the boats just go out of the water and the props are airborne. And it just stalls. This will keep the props down and keep the people alive. Anyways, they had a pretty neat product line, and basically there's a bunch of boats to show you that this technology that we developed were on all kinds of stuff. They're just trying to sell it anywhere. This 40-foot catamaran, that if you see the bottom, it has an electric motor. It would actually get itself up on, using the big motors to get itself up on the plane and then just go to pure electric. That was their other concept, is like lift it out of the water and then run on a tiny electric motor down there. Once it's lifted, like Roger's saying, he recognized the drag goes down, and immediately you need very little horsepower to move it very fast. And these are other boats. I wish I had better pictures. I just got them off the internet that the technology works. And this little thing, T-Craft, this is actually, this is not, this picture obviously is a fake. This is a toy. We built a model, literally it's about 2.5, 3 feet long, and it's supposed to be fit the largest, I think the Abrams tanks, 2 or 3 of them in there. We built a tiny model for the Navy. It actually did work. It had you can see those 2 rotating tracks, and it literally built, I'll show you the little controller, it literally just made it, and it did something, they didn't even believe it worked. It went up a thing that would be the equivalent of going up a 30-foot wall. That thing's big, I mean, no doubt, but it was like going up a wall. It's like these toys. It would literally just, it took the tracks and went up over it, and they were impressed, but they still haven't been able to sell the concept to the Navy, why they need a landing craft to do that anymore. And these are a couple of the other boats. This is the first boat actually that was a lifting body. It looks like something from Star Trek midfoil. It's in the water and out. It had one of the rudimentary controllers on there, and it's been upgraded. And this is one of the first type of, I upgraded that one. It had a really dangerous control system on it. It was the first foiled boat in the world built by Boeing and that, and it really had some problems, but it worked in its own way, just in a dangerous fashion, and I came on later to modify it. And this is the biggest project I ever did. It was it's a Seaflower, and this thing is this. I mean, the area on the deck and in the 2 halls is like I don't know, 14, 15,000 square feet. It's like it's a giant, it's a mansion on water, and it actually, I wish if I can get the Wi-Fi later, I can show you it. It actually is lifted off the water when it's gone. There's a gap this big, and I think they're going to go under that in that video, if I can actually get it later, under like the Golden Gate Bridge out in the ocean. And it's for something that big to be moving that fast and that high of the water, people don't actually believe it occurs. And it has serious problems because it was adapted from a hovercraft. It was a Navy hovercraft. It's super light. Well, the problem with its super light and high deck and everything like that is it can flip over very easily. So it had to have one of the most complicated control systems imaginable. So anything fails, everyone isn't. I mean, it's really big. To go over is just not a nightmare. This is my boss out there, Gary. He's not actually that tall. He's only like 5'4" or something. It's not like, but the boat is really bigger than you think. And this is basically the thing that lifts it. And there's like tubes in here, like, I don't know, 28 inches in diameter. I was the biggest guy ever to get down in there to work in the, like we had all the hardware in there to drive it. And just because of the shape, even the size of your femurs, you could not get down the tube and get out the little opening to do it. So it's pretty exciting work to deal with stuff like that.
What kind of drive systems do they use?
What?
What do they use for engines?
That was like multiple 2,000 horsepower turbo diesels.
Turbo diesel?
Yeah.
So they were reciprocating diesel.
Yeah. But the biggest problem with this was it had to have the best drive shafts on earth. The diesels are like way up here, up above here. The drive shafts had to go back, way down here, down and way to the back. You can't see it, and the props are in this lifting body. And every one of those joints is a bushing. And the tiniest, when you're driving like 4,000 horsepower out of a thing, the tiniest mismatch in like the bearings and it heats up the bushing like crazy.
Right.
If you get like 99% efficiency, it'll burn everything alive. The alignment of these shafts that go down there, and you have to be super stiff, special stainless steel to actually, I mean, to make that kind of thing to actually make they call it a jack shaft. It's basically a Z with a couple bushings, and it's a big deal.
How
And
come
I
they
didn't work
don't
on that.
come down with a low RPM shaft and then
You
go
can get it
to-
up down there.
But
Yeah,
the horsepower is
check
still
it
the
up here.
same though. So, yeah, you're right. Actually, the props don't turn that fast on big boats like that. It's a function of the speed and the curvature of the prop. I'm just saying is the torque on that and the energy that comes through that actually, if it's misaligned, it goes into the bushing. Okay, it's not just even a speed
Right,
thing.
it doesn't drive it through as soon as you deviate from geometry.
Yeah, from
You're
perfect
that-
center, it's now pushing on the side. That energy
Right.
goes into the bushing and it heats up wildly. I mean, when you're talking that high horsepower and aligning those things a very long distance is difficult, the drive shaft. It's not like shafts can be infinitely long because they twist and they bend, and that's what happens against the. It's a big deal. The mechanical engineers that did that did a great job, and anyways, this was the prototype for it. And what you can't see here is, well, I'll do it with this, this is, you know, up the top, there's 3 monitors. This is a triple redundant system because it couldn't fail. 3 monitors across the top. There's a whole rack of equipment here, floor to ceiling, full of circuit cards, all interconnected with these yellow fiber optic cables, and this rack also. And there's like, this is a monitoring computer, another one that drove just for software development. This is a display, which Tyler will show you, we got from Y10. So one of the first things I started working with them, that they actually did some custom design with us to work with this thing. And it basically, it's amazing amount of stuff to put together. I did this with my system software guy and made it work. Anyways, when we, let's see, this thing is not paging up or down. Oh, and using this mouse is not correct. Alright. Basically, this is just what one of the 3 they call control computers look like. That was this thing here. Basically, it's OEM boards, a stack of 7 of them that you buy from other manufacturers, put together with our software guy, and I designed this board, had it built at Y10. It's about the largest board blank you can get, period, in the United States, even now. When you get they're like 24-inch panels, you can get that 20-some inches, basically, in a direction.
Is that
And,
the biggest PC boards come in?
Huh?
Is that the biggest?
Well, the panels, their panels are only this big.
Oh.
So you can make them, you can get 2 of these on a panel. They can only go 1 more over there. The panel they use to dip their dipping tanks, they're just not, you can't make boards bigger than that unless I don't know where you go. I don't know if you go.
There's places to go. I've seen bigger boards for like semiconductor manufacturer companies.
Are they like twice as big as this exactly?
They're like round, like
Oh,
this
but I mean
size.
twice the diameter? 'Cause it's like you're stuck at like 24
Not
inches.
twice. They don't get much bigger, and
Yeah.
they get really.
3 feet is pretty much it.
My 3 feet might be. Most of them, they're 2 feet is what you're talking about. Yeah, it's 2 by something. It's this size, this big, and that's not 3 feet, but that's.
And
what's
it's
easy
really
to go.
really expensive.
Anyways, this is one of the other there's this stuff forever, and there's another rack you saw behind it and part of the monitor. This is a pretty big system using these boards, and to show you how we put that together. It had 14 computers or instruments this worked in, 4 passive devices. It invented 5 models of 37 cards in these things, and 24 custom cards that I built 4 models and worked with Y10 to do that. This is an example of just what people expect. What I deliver is you actually give them a block diagram. And each one of these is multiple buses. This is a connection. It looks like a connection, but it's each arrow is a series of connections that you put together and put the people. So it just shows you that this is like as far as you can imagine going with that complexity of the system, or I can right now. And this is displayed, like I did the software for this to actually get a display. There's all these fins and surfaces, and all those represent one. It's just so you could watch, operator can watch what's going on and monitor everything. The thing was, it can monitor how high, its height off the wavefront, what it thought it was doing, and basically it, well, let me see this. And this was pitch angle, and they'd set it, and pitch angle, the thing was pitching. They knew if the boat was going up and down. They knew what the things were doing, and all these other things were alarms that any system was going down. Even though it was triple redundant, you would give you the idea you lost your redundancy anytime any light went red, and they pulled the plug. Anyways, this is the smallest project I built, and it was a laser diode controller, and that has an interesting thing, and I'm going to go through the evolutionary design thing later and discuss that one because it's the antithesis of evolutionary design. And basically, the current project I'm working on is I wish I had a better picture, but a sonar parking aid, and I'm going to go through the like it's a good time to just start saying this is how a project goes. This is the current project we're working on right now, with his dad, used to be president of Whitehan. And it's another current project that we're working on with Tyler. He's doing a lot of the work on this with and Roger's like the patent lawyer, and his client is one of the guys who's kind of should be one of this group, just going to him and wanting as an inventor, and started this process. Okay, this is the biggest page. It's really short, but the problems that I see everyone has is it's how you execute it, because you can be dead in the water if you make mistakes and you'll never recover. And the big thing is technical, is I believe in evolutionary design. You got to get to a prototype quickly for two reasons. Technically, it may be dead in the water. And marketing, it's not what anybody wants. You're like delusional. Your customers go, huh? When they actually get kind of a prototype, you really have to realize very quickly where you're going, and people have all these ideas and think everyone will love them. They don't. It actually reduces risk. It appears to waste resources by doing product phasing and saying, oh, we're going to rework it at this point and rework it again and then ship it. It actually reduces waste because you refocus on what you're really doing. You go, well, this is too big a project, or this part's easy, and you basically recalibrate at different points, and that gets you to where you're going quicker and cheaper than what I call the Big Bang theory of everything at once. And what you got to talk people out is don't reinvent wheels. When people ask me when they have a product, I said, I even do this with mold designers and CAD designers. Say, okay, show me what you made. I want an estimate for this new product. I said, it's kind of like that one in the number, 2561. What did it cost you to build that? You do recognize that. You don't want, as an inventor, you want to reinvent the most important thing that's unique to your product, not just everything. Because that just ends up being just a giant financial and technical disaster. Financial says the budget affects technical past. Be realistic, because we ought to tell you what you can do with your resources. Some people, they just can't get there with the resources they have. And what you really have to do is work with somebody, even if it's not me, is individual prototyping costs are high per unit, but they always should include planning to a path to get, well, this is what it'll be once you get to 20 units, 100 units, 1,000 units. And basically that's your goal, is you're probably inventing a large volume thing, and you have to have a path there from the beginning, or you're pretty much done. You basically hit a wall and you're done. You start over. Strategic is like work on the right problems, and that's just a general thing to say, but a lot of people get off on tangents and they're not really focusing on what's unique to their product and what its problems are. And assigning the right people for each task, not just who's available or who wants to do it. Sometimes you're just going to have to really think really hard and get the right person in the right place. And the other part is, this is what I do relentlessly to customers: reduce product complexity to a minimum, but no less. You make it too dumbed down, it doesn't work. But people, and I'll show you, come in with giant, what I call the laundry list of what something's going to do, and then that just never happens. And the other thing you need to give your designs to everybody is you got to get accurate surveys of your customer requirements. You just can't say, we think they like this. And so you end up with, like I said, a big laundry list that just never goes anywhere. And then for you got to tell designers, what's your sales price range? I mean, you can also say, no, we can't do that. That can't be sold for that price. You're never going to get there. The customers won't buy it. Their price higher, then it's no point in going there with your invention. And the third thing is time to market. Everyone just thinks, oh, is it done in 4 months? Or some people wait way too long and miss a marketplace, taking years to develop a product. So there's a lot to it, but part of it, you're an inventor. You got to actually think, what does a customer actually need? Accurate. Try to get accurate product sales price range. What would they pay for such an object? And when will the market end for us? I mean, how fast do we have to move? This is the one I'm working on now. This is the prototype phase. I'm going to go through this really fast just to give you an idea of really things how it really goes. for example, I get this thing, I go to a meeting, and I end up with these guys that talk to me about 3 systems prototyped in various ways, with all of these, okay, all of these, you don't have to look at them, just say there's a lot of requirements. Then they said, okay, here's one of them, and one of the variants, we're gonna work on all of these. And we're gonna have these specifications for that one. Then we have this second variant that they decide we're gonna try this. And here's our specifications for that, even longer. Here's our third variant. We're working on these. They said here's the 3 different types of customers, right? They're going at it like every customer they can think of in every application. Okay, and here's their specs for that. Okay, now, and then they have a TBD stuff and who's going to do what to work this up. So in the end we go, okay, I come back to them with a cost thing. I started with 3 separate design paths, each with the wireless option. I ended up with 1 path with 2 wireless options just for patenting purposes. We're like, okay, that's our future. And we designed and built 1 option. Okay, basically had to fight them down from many pages of stuff, and that's normal because people don't recognize they're not focused. And so they get a proposal that looks like this, and this one's really short because I've known Andy for basically more than a decade. It's at White Tan. He said, my thing is, short period of time we'll consider only one, and it's the 4-channel wide beam with prototype system. We'll see how it performs and then consider the other options and cost estimates. So just said, all right, let's bite off 1 piece. We cannot bite it all off. And you get an estimate like this. You always have system architecture for me, detailed design. There's circuit board assembly, that was basically YTN, and then I say boot software, so it just is alive at this date and this cost. And the same thing, we're going to have to modify it because that's just how it goes. And it's going to fit to that date, and bench test the software, and bench test the whole thing, road testing of this device, modify the hardware again, rework the PC boards, and it basically just telling them it's going to be reworked a couple of times, and up front, and this is what it's going to cost. And I blocked that out because they were confidential then. It's probably confidential now, but you get the idea. Is getting a proposal for just too much is bad, but not having any rework in there is really unrealistic, and you're probably going to have to expect something like that. And the design flow, just to show you what happens, is so then I come back to just one block diagram of what we're going to do. And he said, this is what we're going to do later for the 2 variants of wireless. I give them a schematic. This is one of the pages. You just get stuff like that and produce it. That's what I call the first, for example, this stuff is called the design architecture, and this is the kind of stuff you end up giving to Roger for your patent. So you have to actually have a design architecture, what's connected to what and how it works. It's that kind of it, Roger. You sort of get a block diagram. That's what you need for a patent anyways.
Yeah, I mean, you have to show that you're basically proving it's real.
Right, the real part.
And it's functional.
Right, but you show the functional block like this always in your patents usually. That's what you see.
Summary block diagrams, and then maybe an intermediate level of detail.
Right, the next level of detail is like schematics is what I've, for Roger, this is the detailed thing.
Sometimes people do leave that off. They might stop at the summary block, but it's a little risky because if your disclosure is determined to fall short, then you can't add it. So you're just, that patent's good.
Right, and then, like I said, this is what I've been requested by patent lawyers like Roger. Here's the parts list. So they believe there's a physical representation possible. You've actually worked this problem, not just throwing something at.
Yeah, you're not. You can't patent an idea.
Yeah.
It's got to be real, and then for the client or the inventor, and if it isn't real, it's not going to sell and make money anyway.
So this is the kind of stuff you just, even though you say it's wasted steps, well, no, you just hand this to the patent lawyer when you're done, because they need this. And then this is basically circuit board artwork. I'm just showing you an example on my screen. That's you take that schematic and make it into basically files that the circuit board company
There's
can.
a name for that software diagram?
Gerbers.
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 The Gerbers are, this generates
Yeah.
Gerber files that,
Gerber files.
it basically, they can read his manufacturing thing to
Oh,
build
right,
stuff
and then that
and,
can go to a, what do they call it?
and a
Pick
circuit
place
board.
machine?
Yes.
Okay.
right. But it also goes to the circuit board designer too, manufacturer. The circuit boards are made from,
Right,
The
because
bare
those
board.
are, they're custom etched, right? And
they're etched from
Yeah.
a file, one of the output files from this. And
Right.
also a file tells them what part is where and how, and where to put down solder and solder mask. I mean,
Right.
literally these files tell the manufacturing guys what to do. And this is what I give to Tyler, because a lot of times there's a handful of parts that do not work with machines, and you just give them an idea of what, you know, instead for an estimate, what you're getting. This is the 3D model board, okay, and that's, you end up with, basically, then you end up with a 3D model, you send it to the PC board fabricator, and then, well, you end up with that, which is, you can't see it well, but that's this. After you get out of white-tan, you end up with this board like this. And that, then you do the software and testing. And for example, this one, this will go away. It has a jack right now for programming because there's an intense amount of software revs that make something like this work. It's just, it's not feasible to do software in that, in a straightforward manner anymore. You just keep modifying it and you give it to guys that say, how's this working? Okay, and then, well, this is it. This is what a software program, and I'm actually giving these listings now. For some reason, Roger's the first guy to ever ask me for that in a patent application. It's just like, okay, I want software listings. This is like one
It's
page of
just
what they
being
start with.
conservative, you know, and also, if it's there, you know, you have it available. If it's not, you don't have it. And
Yeah. No, this is what, it's just basically, it does show that there is really a product there to the guy. Okay, they'll even listen
and
to
this is all like programmed in as your firmware on the chip, right?
Correct.
Okay.
You program it through this jack, and then eventually, you can either buy these from distributors. It's in there when you freeze the software, and just buy them with it in there.
Okay.
But until you finish a lot of your cycling, you just never do that. You always, you reserve the right to change your software, because everybody has a complaint about your product always, and you got to modify something.
Okay.
And then we go to refinement. This is a perfect example in Rev B. Refinement is say, okay, we're using one sensor, that seems to work fine. And a couple other things, we cut it down to almost nothing. And we end up with this little, we end up with this, right? So we don't need all that stuff. We end up with this thing. Okay, so now this is cheaper to build. It's leveraged off of that, but it actually, you know, that's where we are right now. So you go from one, the guy's thinking, oh, we just need 4 channels and 4 sensors of this thing. He says, no, it works.
So you like half the size of it. It's
Right, it's half the size. I mean, it basically is half the size, and it's also doesn't have all the capabilities, but they weren't actually needed. They were, like I said, over speculated in the meetings. I even cut them down, way down, and it still is like, no. When we finally built it, it works just fine like that, and it's way cheaper.
What does that cost to produce? And then where do you have it made?
Well, it's a
Here?
prototype run. I made it white tan. Okay, so basically, the thing for this right now is this is super cheap right now because I designed this to fit this readily available package, okay, off the shelf. Didn't have to go to mold designers, didn't have to go to CAD designers. I designed a board, say, okay, I think I can fit it in this one, and was able to do that, the size of Don. And the same thing, that was designed around a box, say, okay, how about that box, can you fit it in there? I'll try. And so that's one of the things you go through is do not, when you start a prototype, it's really nice everyone has ideas of designer packages. Say, well, that's going to get expensive quick if you throw them away. So why don't you just get something, I always promote just like Tyler will do the same, beat the same drum. Get something out the door right away for a customer to look at that's sort of like what you want, and then see what happens. Like I said, we already went from something that big. They said, well, that's really unwieldy. This thing will eventually, I mean, we have a wireless version where this eventually will be just clipped to the top of your visor in your car. That's the ultimate goal. But anyways, that's why the sizing, all these issues, just this evolves all the time.
When you're asking how much it is to produce,
Based on, say, 1,000 on or something.
yeah, exactly. I mean, the cost to do 4 of them is going to be, you know, $400 a unit because there's tooling and non-recurring engineering that goes into it. But when you do 1,000, you know, a circuit board like that should be down to $8 for assembly, and then maybe it depends on the parts. Besides that, so if it's got a crazy microprocessor in it, that's where all your cost is going to be. If
So
it's,
who puts that together? You guys do? Or
yeah, YTAN, which we're right down the road actually, and Vesta's one of our clients too.
Okay.
So anyways, yeah, that's part of it, is you really have to understand the difference of buying 1 or 4 and then buying 1,000 is so grossly different. And guys don't recognize that. But you can't build 1,000, better not build 1,000 until you actually get the bugs out. I mean, you just don't, there's just no way to do that. And another thing is, like, the next project I worked with Tyler, is yet a longer memo, because I never worked with Kevin before. He's a client of Roger, and it just said, Kevin, I'm going to phase it in 3 phases, okay? And each one, it says, we're not going to bite it all off at once. And that's all that says. And I said, and you know, it's going to be, I get down to phase 1A specifics, phase 1B, and phase 1 is broken into 3 specifics and timelines. So we're like, even the first product we go out the door is already going to be kind of put out there, then slightly reworked and slightly reworked again. So I always get him a heads up on that, and I just want to share that's what I normally do, is that, all right, we're looking ahead. And he has 2 other phases in his dreamscape of his product, right? But this is like the first phase. The first one takes A, B, and C of just 3 rotations to get that out the door to the customer. And then that's what I'm speculating. And then just, and basically, so I end up, okay, I give him a drawing like this, and this goes to, basically goes to Roger for the patent thing. I did all the, well, behind it, all those other steps. There's software, you know, circuit boards, everything. Don't want to go through it again. It's just redundant at that point. And you end up with this thing over here.
Right, now show them what the original looked like.
And yeah, Tyler, why don't you go through that, Tyler, the evolution
Okay.
of it.
The analog.
The very first one is down there on the left on the ground, and it doesn't really use a circuit board. There's like a timer and some other parts.
It's all analog.
And yeah, he's probably got $100 worth of copper and brass in there. So then the unit to the right in that little box, that was like the next round of prototype. Obviously, John did a circuit board, and we integrated that into the control.
Yeah, if you want to look at this, you probably want to come up and see it. It's just, it goes from a thing that's basically a relay generated and wire architecture, and it didn't really work well. It really it just wasn't very flexible at all without a computer in there.
So anyways, the next one down, you know, we just did whatever we could to cut costs and make it smaller and not lose any of the function. Again, integrated the circuit board, and then yeah, finally right here we have what we call a production prototype. There's a bunch of junk in here which actually goes externally, but yeah, basically you've got just a few parts that he needed, and it's at least ready to, you know, bring to the patent attorney. He could start to sell a couple of these. It's fully functional, and it doesn't look like somebody made it in their basement.
Ready product.
What does it do?
It's a leak detection and shut off system for houses. I think it's mainly meant for like vacation houses. If you're not there, what you do is set a timer, and if the water runs for any reason longer than whatever time you set, so if your sprinkler system is 10 minutes, you set it for 11 minutes. If the water's running for 11 minutes, it detects it, shuts it off, and then calls your cell phone and sends you a text or something like that.
So aren't they competing with somebody, or is this the
I think the main thing, I don't know exactly what the patentable aspects are, but one of the main things is it can detect a smaller leak than what's out there, and a lot of stuff.
It does a branch up the main line through like the operates like your ice maker
Yeah.
is pulling in a little water, say in your refrigerator or
Yeah.
something.
But
And
this
so
is
it has to
time.
like bypass that and distinguish between that and a real leak.
Yeah.
And then if it detects a real leak, it shuts down the main and then
Yeah.
it sends a message and makes a call.
Cool.
But it's actually like, it's like 0.03 gallons
You
per
could-
minute. It's really small, can detect, okay?
Yeah.
That's part of his
We've
genius.
already got a patent approved on the first version, believe it or not. And
So,
that's,
but
that's
is
just
there
on the
anything
fluid.
out there much, or they're really on a bigger scale? Where
They
they're-
just, there was a couple close things, but they
Basically,
they
you
were
have,
in different
Cause
applications.
they'll sell the crap out of them.
yeah,
Yeah.
there's flow sensors of all sorts. Nothing really meant for a house main shut off when it detects a leak.
Yeah, most of them are for closed loop systems like boilers. They're actually, the
Yeah,
water
specialty
is moving.
applications.
Yeah, that is
Not
on
like a
both
general
sides of the
building.
system and it leaks and they notify it. It's like, no, this one, it's off. That's a big difference if the stuff's off versus it's flowing in a system. Like at pressure, basically the system's pressurized. The second thing is he correctly surveyed human behavior and determined, you can set a timer on this. This has all these, you can see it on here, there's times. It's basically a time delay of when it will not react. So you can actually live in your house, take showers, and he's surprised. He said, you set that thing, he said, to 30 minutes, and it never goes off. No one takes longer, well, he doesn't know my wife, but 30 minutes. But if you set it to 60 minutes, you will not, you have the tiniest leak, like your toilet, like 0.03 gallons per minute, doesn't give much water. In 60 minutes, it will say, you always, even your ice maker, everything always shuts off unless it's malfunctioning, everything. Irrigation systems, everything in your house, toilets, everything like that.
And it's a big problem with
Yeah.
ice makers and stuff. They can have a slow leak, like underneath or in back, and then
I've
people
seen
never
many
move it,
times
and
to
then
that
their
rental
floor
job.
starts to rot.
But he had the mental thing of, oh, water doesn't run all the time. So people have leak detectors. It's also, if it leaks at all, so they set it to 0 if water's going out. Well, everybody has a boiler knows there's an expansion thing in there in your furnace. Tiny bit of water goes in every once in a while, the expansion tank, and that would set it off. You gotta not have constant false alarms. If he's able to think it through, that you can set the timing and you do that well. That doesn't work well with timers you set mechanically, but with computers you can basically set it to just ignore extraneous events. Very well, you just keep writing software like what's actually a noisy glitch in the system, what's not, and what's a real leak. And computers are really good at that, to monitor things and decide if it's a leak or not. It works surprisingly well, and then when we thought, oh, it's just going to work, it just does work.
See what people do now is you can buy moisture detectors. You
Sure, I
can
have
put them
those.
under your
I have them
freezer
all.
and
Yeah,
your
they're
ice
types.
maker, and you're doing this all individually, and it's kind of like clues you uncoordinated, and this covers your whole building without having to do that.
What's the goal retail price for a residential home?
See, here's the problem. This is something really frustrating from my end because we see lots of people with different products and they don't do market research, or they're paying somebody a lot of money to do market research and they have nothing to show for it. But it's like, sometimes I am left with the decision on how should we package this, how big should it be, how heavy should it be, things that a marketing person should have figured out, and especially price point. Right now we're looking at like a $1,200 system, but I think realistically he's gonna have to bring it a lot cheaper. But
And we have actually designs to replace a ton of that already, a product. And not too long in the future, like 6 months down to the $600 to $500 level sales level.
What does
But-
he spend with you guys from that initial pipe over there to this so far?
What did he spend?
How much money has he spent with you guys?
Um,
No, Roger, but.
This, I don't know what Roger's charging. So
It's
what
less
I'm
than
looking
that.
at is
How much has he spent with you guys?
to get
you've done two board revisions.
to get from here to here was probably like $12,000 total.
I don't know. It depends how much you charge them.
No,
I mean,
I think with all costs that I've seen, to get from here to almost to here, and then at a certain point, like I became his partner, so then the costs have been just really $13,000 to get to there. Okay, so now we're at that point right there, and
Basically, to do a revision of a board, we're doing like 4 pieces, which it's basically as cheap to do 4 as it is to do 1 because it's so expensive at low quantities. Basically, it's like $1,000 to $1,500 every time we do a board rev, just for the board, and that doesn't include parts, So there's a lot of
parts
variables.
weren't that much. It's literally
No.
like I
So
said,
we basically there's about $2,000 to $3,000 to get the circuit board
yeah.
to this point just to build the board. There's about that much in engineering.
Yeah.
And then there's all this work we've done with plumbers and machinists and stuff
Yeah,
like
but
that.
it gets cheaper faster. The first thing's like, okay, you're at this point, you're in at
But his
$12,000.
his focus now, I
Then
mean,
all of
when
a
he-
sudden, a few $1,000s later, you're right there.
when he
Okay, the
goes-
next one, it's just as you refine it, it gets quicker and cheaper. The first thing is always there's so much.
The digital part's gonna get cheaper with volume.
Yeah.
Really inexpensive, and you amortize engineering. So his problematic focus now is the major fluid components, which is the shut-off valve, the flow meter. Those things are
Shut
still
valve.
kind of costly, and they're not gonna come down much when you're buying them from others.
Yeah, but we actually have a solution for both of those sort of on.
Yeah,
We're
they're gonna
already
do
working on
their own
revs.
design flow meter.
We already got, yeah, we've already designing, and we can't release it because we're going to be talking to Roger about a patent for that, designing a system that replaces a lot of, like.
Yeah, the 3 most expensive components.
So if I go online right now and try to buy something like that, what's there?
You've got
There's
flow
something there, 'cause
sensors. You've got like PVC flow sensors that will, tell you if there's water flowing or not.
Uh-huh.
It's not going to distinguish between anything, and it's there's no computer system hooked up to it. It's just going to give you a voltage reading across 2 wires on
A
the other end
signal.
when
You're
water's
just getting a
when
signal.
water's running.
And they're
through.
really crude. It's not like 0.03 gallons. It's like if it's a big system with a 1-inch pipe, you're going to
Is it on or off?
many gallons. It'll know if gallons are flowing or less than a gallon's flowing. I mean, not like a whole lot of usefulness in there. The other thing is for leaks is you put leak detect like the equivalent of ropes down that when they get damp they short out of contact, and then they do that, and that's what the company. We're actually not inventing the wheel. What this is right now, another phase, is just right now this thing uses a dialer. This dials basically people's phones. Just buying it because we don't want to reinvent that wheel.
It's the call you don't want to get.
It calls you up and tells you what, it just calls you. And basically what that does, it has a leak detector part of that, and that was in this unit, the black little board there, and it gets wet. Well, that's just it. They said, well, you can put them everywhere in your house. Is
I
that,
have them in my rentals. because
no, but is
they
it, where do
break and they
you
make a
put
mess.
them?
You just buy
Everywhere?
a bunch and you put them everywhere. They're everywhere.
Yeah,
Under
exactly.
cabinets everywhere.
Yeah, I mean,
You gotta
they're,
change the batteries,
oh yeah,
Oh,
no,
right,
they're
'cause
everywhere,
they're
and that's the
self-
problem.
So
with
what
everywhere.
what
Sign
John
up
ended up doing
you-
was he designed his own version of it, of those.
Oh yeah, the other thing is just this is just for Kevin is because okay, we ain't paying $15 for that little thing, and the design these are like okay, I did this for Kevin, and we had to spend $650 to get the boards built, but then we have like 500. So we have 500 leak detectors. That was the deal, and they just work the same. And just say okay, that's what you do when you do it yourself. You say you can't just buy everything from manufacturers. You just make this and say but. To buy it in quantity, it's a special thinness of the board. We didn't want a thick one, so I had to go to a non-prototyping project. So I did buy an entire panel of them, which is 500 boards, and like we have enough forever. For 500 products. But I mean, but it's like let's say when you scale it up immediately, circuit boards are really cheap. That's enough of those, and one of those goes in each unit because we wanted to say this actually will know when it is this part just in front of the flow detector. It could be leaking right here. Okay, so the thing is you want to tell them, no, it knows when it's leaking. It has a problem, and that's just a feature to the user, and that's why we still include that. And it has things like, it senses temperature. So if it's in a cold place, like your crawl space is getting too cold, it will tell you that also. There's a lot of different features on there added to it. And it has hooks in there for hooking to other systems, like security systems and other stuff like that, to actually, they can set that off. But like I said, there isn't anything that's convenient, just stick it in there and just work. It just does work. And Kevin thought that through. He said, I tried this, even in his crude model, which we barely envision. He said, it just does work. You can take a shower and it doesn't go off, the timer. And he didn't know what to do with it, you know, and he just had it to a reset button. So he says, well, when it does, you go down to the basement and push this button, which people don't like. So, but anyways, you make an automated system to people, and the next level is there's actually, yeah, you know, we have actually a Rev C with a digital patent with Roger, which actually is a wireless version also, which is fashionable. If they want to know a Wi-Fi,
Well,
the
you
same
can-
information.
Sure.
You can
It
get
just-
online and see how your plumbing's doing,
Right.
wherever you are in the world.
Yeah,
Well, you
right,
can-
they'd be doing that, yeah.
Connected, you know.
Right, some people like that, other people want to be notified by the phone, and also, yeah, our plan is to also, mine is to really be connected to security companies that it's compatible with that, to actually notify them, be part of their system, that they claim they offer water leak things, but it's more like leak detectors like that everywhere.
So 5 years from now, what do you think you're gonna be selling that for? Cause it'll sell, I mean, I
Couple
buy
hundred
several
bucks.
of them, yeah. I'd buy it for 200, I'd buy several of them.
Yeah,
Right now.
it's literally down to that level. What it really comes down to is volume on, like, for example, this thing right here. This is really kind of expensive. This flow sensor and this whole rigmarole right there. We've got a prototype we're working on right now, and
It's an 11/16 thread, so we have to custom
yeah, everything
make
is
the
crazy
fittings.
about the products you buy off the shelf. The threads, we have special adapters, all kind of stuff, and if we integrate that into one unit, we dropping the price dramatically, like to 1/6 of
Yeah,
its
maybe you could,
cost.
you could cast or 3D print something that all those flow paths.
Oh, we are gonna do that.
Hold it in, and you don't have all the connectors and assembly.
Well, no, we actually machining a thing to do that first
Okay.
before we, because they said you have to have a CAD designer to cut out the 1,500 to $2,000 to pay the CAD designer, and it's 500 to 1,000 to print it. Why don't we just get a machine? We'll build one and then we'll see how it works, as opposed to start printing them. It's a little crazy just to throw money away sometimes. And the real procedure is to get a prototype to work. Because we probably gonna have to, what I call futz with it, is just all the sizes of, just the way it works. You're gonna be probably putting in epoxy, shaving parts out of a thing, and then you take
Right.
that to your mold designer and say, okay, this kind of works. Will you make this out of plastic for me? So we have a plan like that. Like I said, you're right. The cost you have to get something out. Does it work? And now it's like, okay, we're gonna sell this actually to high-end customers. He has some that'll buy. And people buy at any price in mansions and stuff, and we can move that. Is what the marketing thing said. At up to $2,000 is what she
Yeah, I
said.
think so.
She can move it.
So
The
can you
potential
do it?
damage is huge.
Oh, it is, you see it every day, yeah.
Right.
So when you write that patent, can you write something, because there's not a lot on the market, something really general that can cover a lot of stuff in the future, or
Well,
not?
it's all based on what it's compared to, but the first patent was approved on the branch flow concept with the small flow meter. And we were diverting around to Chuck valve. And we basically only had 2 other patents that were remotely close to deal with. And they both did it slightly differently, and that's what pushed it over. 'Cause
None of them
Kevin
got
was
it actually
surprised
right.
He got a patent.
No, I reviewed their patents. None of them got it right, and Kevin got it
You
right.
saw the other 2.
Yeah,
right? were
they didn't
kinda
get it
close.
right though. They wouldn't work that well. I go,
Yeah.
no. They were close, no cigar, and finally Kevin got it right. This little loopy thing you saw, he got it right. Okay, so and he also got the part about it for the low flow sensor, but he got the idea of timing the thing that would actually work, so you don't have to it doesn't go off when someone comes in and turns on the faucet or takes a shower. It actually, you can set it for, you can live with this thing, and then when you're away, you just go away for the night or a weekend, and all of a sudden you get a phone call, the water's been on too long, this tiny amount. It's actually, he has 2 levels of ingenious. He made this thing work, that flow thing, and he had decided, I can make it work and people can live in their house at the same time, not just a vacant house. So he has 2 different things going for him in in his thought processes, which is really cool.
So are you able to develop a circuit board that memorizes like they have on a thermostat, memorizes what your typical
Oh,
use is?
yeah,
and all?
No, that's like the next thing. We're not adaptive right now. We've been thinking about that.
But could you design, or do you have the skills to design that?
Yeah. Well, we right now have a thing where we ask them, you see this, it's set right now, decide what your thing is and see how it works. So you just turn this basic screw knob and say, that time constant isn't working for me, okay, and for my lifestyle. And that's the first phase. Yeah, what you're asking for is that thing where everyone says,
There's that patent,
Where-
but they can't use it on
The
that.
Nest thermostat does that, it learns your,
But
Right.
could they use it on that, or would they say, no, you're violating that patent?
I don't know, depends.
but it's
on
not
what it
temperature,
is.
but it's for water flow. It's water flow. I mean, monitoring people's
Yeah.
stuff is a time tested thing of monitoring it, just saying your average thing is this normally, and it will, work for a while. But that's, see, you're asking for a thing that's like the guy said, the laundry list is gigantic, and you never get anything out of it.
Well, you're talking about the dude that lives in Cherry Hills Village or something.
Right, but
He just
yeah,
wants
the next step
to-
is, what the computer in there is really powerful does for you is you can now make that leap with just software revisions. And that's why I say it still has the programming jack on the back of it, because we're just gonna go forever. For things like you say, you're the marketing guy, like you're the guy coming and says, well, I don't like how that works, I want it to work this way, right? That's exactly what you want from marketing guys, and say, can you do that? And I said, yes. And then you tell them how much money does it take to do that.
Yeah.
Just speculate.
And-
But you actually leave the hooks in, like I said, it's, the processor is way more powerful than what anyone would suspect for this function. And there's another reason for that also, is because I used it on other projects, so the software boot program was instantaneous, or within a day, as opposed to people say, well, I can get designer on a new processor and almost, for small stuff you develop what is almost like an operating system around a microcontroller. They don't call it that, but they do that, and it really takes a lot of software to build it, and you change that, you rework all that work. So it's best to, that's almost like half that software is a cut and paste thing from other projects. It knows how to wake up and say, I am alive, and do stuff. Now, and you work only on the specific task, to this, not to just building. Like I said, the reinvention of wheels is expensive. And if we want to get costs down even further, we would finally say we've locked in all the software power we need. Now we say, okay, we'll go to a cheaper level processor, less capability, and try to save. We'll be talking about saving at that point $1 or $2, right, out of each unit. We'll be selling a whole lot of units. We say, can we cut $2 out of this thing? Okay, different that's the level when they're selling 10,000 units every couple of months. Then you say, okay, we can afford to just do them all.
$1 makes a big difference.
Yeah,
Yeah,
we're-
the volume
we're-
will just, $1 will make a difference when you get to that level.
We're
For us
still
right
at like
now,
$600 to build this.
Yeah. When
And
you go to
300
600 to
just in
599,
parts.
no one cares. No one
Don't you
cares.
think you're gonna be in court defending this? I mean, that's a big thing. I mean, everybody's gonna want it. So somebody's just gonna copy it and say, oh, it's not close enough.
Yeah, we'll
Yeah,
just,
yeah,
Well, it's just how you, I mean, you
that's
always
where
have.
our apparent power of the patent, hopefully we can, get some license agreements, or just stop
Yeah.
them without going to court over it.
But like their stuff just doesn't work.
Or just, the thing to do is get your major infringer to buy you out.
Well, the other thing that Roger, he did say the other one was slightly different. This one is like, one was a closed loop system. It's for boil. It literally, there isn't an output of water. It's a system that never water ever comes out. It just
Yeah, this
loops
is
back
open loop,
around.
so.
And the other had some other different, the applications were different in the technology. But his is kind of a conglomeration of both of their patents in a way, and a third part added on top of that. And that is what
The
Roger
nice
calls
thing is
new.
this area of the prior art, there just, isn't much going on, so you don't have to deal with much.
Well, that's what I'm wondering if you can write it a lot more general.
Yeah.
Mhm.
Because
Yeah,
you
his
get in on those.
patent search is 2 guys over the entire lifetime of this country in that area. It's really, really low people who talk about this. But anyways, that's an interesting product because we're right in the middle of that now. Like I said, we're moving from that to this, and then the next level is just getting the cost down, and then it's like the marketing levels. Like I said, we always, when I said get marketing things, you get it out there, and you'll get comments like yours and say, well, how, is that really useful for it to memorize people's stuff? And that's, it's kind of doable, and I look at that, but right now they get a product off the ground. The fastest way is to make them make the decision, and if it doesn't work, they turn their button to the next longer length time, just for their household. Okay, that's just make them do some work for now. Because otherwise we wouldn't have anything out the door. This, Kevin just started letting the contract, it was in October. Okay, we're moving from October through all these cycles, so pretty fast. And that's really good. Other ones take way too long because people want too much and they're too indecisive. And it's just, Tyler said it's really good to get something out there and start, plus to get cash flow if he's got
You
high-end-
gotta get some cash flow.
Yeah, he's not spending a lot of money, but immediately you just sell the 4 prototypes. He's talking, okay, here's $8,000, and he's going to, okay, can we build almost 20 other prototypes for that? The next level, because the cost goes down at buying all those parts at 20. It's like, oh, we can almost cover that cost, and literally go from just, okay, move those 4 to Kevin, and we're going to, okay, now we can build 20 and talk to the marketing, move those 20. And now I say, okay, now we can build 100 or more with that money. And that's kind of how we're approaching it right now. It's like, and the price will keep coming down, like each one of those volume things. So they, can you move it at this price? Okay, you picked off the early users and people with a lot of money. Then you go to the next level, people that have less money and less inclination to buy, and you keep working your way down to your general product. That's the theory anyways.
Yeah.
So I don't
What
know
he
how
needs
it's
is a
gonna work.
contract with a security company, like ADT or something.
Yeah, they
or
want
a-
it to be really cheap though. We have to
or
get
a-
up to that level of the hundreds of dollar things versus.
Well, they wanna work all the kinks out. If I was an investor, I wouldn't be given that soon, so.
Well, yeah, unfortunately, I've heard that. In fact, you talk to even venture capital, they want all kinks worked out in really good cash flow before they want to talk to you. So, yeah, like I said, working out the kinks is endless revisions. And another one, this is the exact opposite. These other small.
How does the sonar parking work?
Huh? Oh, that's this thing I showed you.
Yeah, how does it work exactly? I put
Well,
that
I'll
in
show you
my-
how that works. I'll just start with this one in line.
Okay.
This was like the exact opposite of what I just told you, evolutionary design. Right? They didn't have a big budget. They wanted this laser diode controller. Had to it fit in there. And because of the battery went in the back, you only have parts on one side. It's a little difficult. And the thing I said, okay, we have very little time to get this out. So I came up, did the exact opposite of what I told you guys. For a small design like this, okay, we got 2 different processes and 2 different ways of approaching the control problem. So we're going to make 4 variants. I stuck it on one prototyping board and got it up there very quickly, and we'll see how it worked. And then we picked one. Okay, so literally, it was like one of these things where the exact opposite of they had a reasonable enough thing, said, okay, here's 2 different a matrix of 2 different processor types and 2 that would see if it would handle the processing load, which is actually really intense for a thing that size. It can just barely make it the one in there. They'll literally compute all the things it has to compute to do what it had to do for the specs for the customer. And I mean, it was actually, the software was really tricky at the end to do that. I mean, it just to actually do what it had to do, and so it's basically the thing was the answer is I don't know. So we're going to build 4 things and see which one works, and one of them did. Okay, that's the exact opposite of everything I've told you. Throw it right at the wall, build the 4 variants, test it, but it's a small project and was able to be successful right away. It's like, okay, this one worked, good. We didn't overthink it by having an intense amount of what I call design phase, where you think about all the problems and simulate stuff. Say, well, let's see what these things can do, and I think this will work. One of these will work. We have a pretty good shot at it, and actually, almost all of them worked, and one was just better than the others, and we went with it. So it was actually the exact opposite of a single shot program that it worked like all inventors would want it to work. But it's a small program, as you can see, and a lot of it's just software. But it was really, that was the easiest thing in the world. Okay, the next thing is this PIE sonar parking, and that's the evolutionary thing. Is like I said, it went from this to, where's that other thing? To basically the evolution was it has, I don't have the sensors with me, but I saw the picture up there. I don't know if you had it up there. Go back. Let me see if I got that down here. Did I? No, let's just go back up there. Oh, there's a sensor on there. We used to have, they had up to 5 different types of sensors. We evolved it. The first one just found out there were 4 of them in this unit, and it was mainly made for parking. And what it did is, if you know what forward and backup sensors are, they're up in the bumper. There's a problem with sonar and radar, everything, ground effect problems. And what happens is when you get close to the ground, none of that stuff works. Okay, so the prior art says it don't work. That was a patent assertion. This is useless. Like, you go everywhere. They've had people in colleges writing papers about why it's impossible to do this. So we just built a prototype and tested it, and it kind of worked. Which, because I'd worked in radar for years, and that was one of the biggest problems we worked on in that giant radar system. Says, no, you can make stuff work close to the ground. It's just tricky. No one actually made, when I looked at the art out there, no one made a serious attempt. It was like professors and assigning their college students this, and no one made a serious attempt to solve the problem anywhere. That
What they
close to
have
the ground
is
sonar.
backup sensors and sensors for parallel parking and
Right,
stuff
they can
like that.
see a car and they can see big things, but they can't see something
Yeah.
this close to the ground.
And the application was sports cars with a really low front end, with apparently a bunch of guys who keep ripping off their front
The other
bumpers.
Yeah,
sports
spoilers,
because they hit a
parking blocks,
parking
yeah.
block is this
They're
tall.
$1,000 to
Yeah.
$2,000 to the average Porsche owner to rip that thing off in a parking block. But the guy, perfect evolution, the guy comes to me, you saw the laundry list, page after page of requirements. He wanted to be going down city streets at 30 miles an hour and see a speed bump because his Porsche had hit those. It's like, okay. And finally we're talking, yay, give him the yay thing. And finally got down to this one thing, we can make it park, and if we get too far away, it doesn't work right. So we're now down to, this thing doesn't do anything within, unless you're 8 feet from the parking block. Okay, it will not respond to anything, doesn't want to look, because it sees things everywhere. Just like, it's really, truly, you're pulling in, and you're going to hit something on the ground 8 feet away. And it's actually really useful to spoiler people, because it just will just tell them it's there. And like I said, just by reducing the requirements, that, okay, we got something simple, it actually does work with, like I said, I was originally brought on the project just to take a guy's thing and make it in a tiny package service mod, but it never really got anything to work, period. And it just designed
Is
itself.
Toyota doing something like this with radar, with anti-rear-end collision?
Right, radar's really
Like
expensive.
it'll see you approaching a car. And it'll
Oh
put
yeah,
the
the
brakes.
cars are really big, and they're high off the ground. They're big and off
So
the ground.
that's different.
You gotta see a small thing close to the ground. It's called clutter, is what they show
Okay.
up, and it's a problem no one's really addressed. Mainly because they had research that says it doesn't work, and it's like, no, it does work. It works. They've done that for the military with radar. They have the same problem. You bring a radar dish close to the surface, all of a sudden the display gets all cluttered, and it's really hard to pick out a target. I mean, that's this classic. Why they have invented cruise missiles was to confuse radar, get them close to the ground, and now,
Okay.
and now you have to. Then they started saying, well, how are we going to see cruise missiles? Blah blah blah. Okay, because those things are coming in too low. They're in the clutter. So it's just a problem that's. I didn't actually work it. It was worked by many guys, but in a different area. Not, the sonar thing. It's just in radar and in the defense contractors and stuff. So it's kind of applying it's an idea. I did it differently, but I knew this is kind of how they do it. And so it's just adapting that kind of stuff to previous work to something, and it worked better than we thought pretty quickly.
Last time I was involved in testing this, we were messing around with like the mechanical angles and height on different cars, and basically we got it so that if a 2x4 was laying flat, it wouldn't go off, and if it was up, it would go off. So
Oh, well, that's
And-
pretty good
Yeah.
resolution.
yeah, and so you're not gonna, it's not gonna go off for a little rock or something.
How does that alert you? Is it an audio?
It's
An
Audio and visual.
yeah, there's
visual?
blue or green, yellow, red, and then the beeper. When you're 8 feet away, it goes beep, beep, beep. You
It
go to
speeds
5
up.
feet, beep, 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 beep,
And you
then
get
a
the 1
solid
foot is
tone.
beeping like crazy when you're getting a foot up the parking lot. But then there's tricks like like what is zero, when you stop you want it to quit, like when you park. And what is zero speed is a real difficult problem. What zero is when there's noise in the system. How do you know how fast you're moving from an object? What, you know, you have to really work the software well to figure out what zero speed is, and so it doesn't go off when you're backing up, but there's noise so it appears it's slightly going forward, you're backing up slowly. There's a lot of issues, and it became, and I know it's a big software project to make it so it, what I call false target detection is the biggest problem. Not detecting a parking block, is getting the things, and that's big, not to constantly be going off and just claiming there's an object in front of you you're approaching when you're really not. And that's the biggest problem, is it's going off inadvertently. And that was the biggest headache with it, is trying to deal with that. Not that it actually worked to keep it from just picking up extraneous stuff all the time, because it drives people crazy. Anyway, so it had like a lot of these, 4 of these sensors, the 5 down to 1. And there are mechanical problems that's holding it up, is the actual, that the machinists built this wonderful universal bracket. It was ingenious. It goes on any license plate. So it's like sitting below the license plate, it's just stuck on there, the stick. But then the biggest problem we found it not working, and we're working through that right now, is that the plate itself was such hard plastic that the sensor, the sonar, was actually vibrating the plate, and it was making the system malfunction, basically, get too much power out, like you now have this giant transmitting system the size of a license plate. And so we're working that kind of stuff. There's always a problem like
They
that.
have sonar lenses, and that would be the way to fix it.
Yeah.
But to get like a sonar lens for the sensor, it's like $120 lens, so it's
Yeah.
out of the question.
But we're talking about sensors that are $10 to $15, and you don't want to spend something. Like, okay, to get a consumer product, someone says, "Oh, we can do that," like you said, for $120. You go, no. That's
Well,
the
but
worst.
you're not
Part.
considering all the-
Yeah, you gotta
Yeah,
keep
you'll have
it
it.
cheap, and you literally just cheap sales price to go in there, because it just adds up quickly, and salespeople want money, distributors want money, retail people want money on top. Prices go up really fast from the manufacturer level, and that's like an evolutionary thing right now with that. And like I said, that the evolution has been with that is yes, we got it to work, and the other one is like, this is a giant system, and if you're doing a product line, this is what you'd expect. Like, this thing we built for a system of, like, there's 3 of these in every boat, and it's stacks of these OEM cards. There's only 3 left I have. I've given them back to the other guy. This high, with millions of wires and connections, you saw those. That was like 3 of these coupled with 13 of these. And then there were a stack of these things. This 7, there was just without the board, only 2 other custom cards, and it was actually taller. Like 4 of those would be a quote, and 2 of those displays that Tyler has, I don't know, he's brought them there. 2 of those displays was a system that was with all those wires. It's really gigantic. Okay, so we're talking about a product line, and I just want to explain it in that way, because then we go to, this thing replaces the thing that's a stack of 8 cards and a thing like in a big red. Then that's immediately it. But it also had hooks in it to partially replace this computer on there. So then we went to a modularized system with this card, this thing, 2 of them, 3 of them stacked together with these cards, and these cards were replaced with, like, some of the functions were just this and this. They were much more rudimentary. So this disappeared. You end up with these 3 parts right there. And adding a 4th, what this did for us is says, okay, you saw like 20 different boats up there. This would work for the big ones, and it would work for the small ones. Okay, each one of these plug-and-play systems now goes into either it's what they call triple redundant systems or singular systems, and they work. So now we have 4 things to work on those boats. And then the next evolution is this is just torn out of a boat. It was actually, it's covered in epoxy for a reason. This was for a Navy SEALs project. They said, we want this to absolutely be bomber. And these are like waterproof connectors. So this thing is in a box that's sealed. This is waterproof on the outside, but then even on the inside, if it did get in there, it's now sealed epoxy. And that's just taking this technology and just throwing it down into a waterproof solution. And for other boats, we added other features. This is high power drives and little fancy controllers and that little function that goes into some of the other sensors we had just to replace it. And this was just a what I call a giant sensing thing for a giant hydrofoil. It would just monitor everything on the boat. We're talking hundreds of things and report it back, replacing a rack of equipment that was 5 feet tall. So then, finally, the last thing in the product line is this thing. And basically what it can do is, that's where they stalled in there at a point now that they're trying to get funding at Navitec, is this has a computing power of like that thing with stacks of things, and that board has 5 processors on it. It's just the one thing that can do virtually, it doesn't have as many channels as everything that has the good features of that. The high power driving in here. It has basically one of those ICs in there with other things do everything basically that this card does with a single IC and 2 ICs and they're this big. So it's basically they condensed this product line into kind of this thing that you saw. There's like racks of wires. They'd be using 1 for a non-redundant system and 3 of these for one that was redundant of these, and they're sealed up in there. That's their prototype box. So they've gone from a room full of equipment and this can kind of run all of their boats. Okay, so we went from a room full of equipment in the biggest boat and then a plug-and-play system. And we still use some of it. Like I said, some of these go with it too. If we needed optical interfaces, which I showed you, this optical is custom, it's using some of these to connect instruments that are not we can buy off the shelf. But this kind of thing is, this took, I don't know, it's 2001 to 2012 to get down to that point, and they get stalled on funding with the Navy. But they're literally, it was like an 11-year process of just making it, and how do we make this work for, not for a boat, for all boats we can conceive of. And that was their basic thing, is just keep refining and using all the technology. And it kept getting smaller. You can see the generation of big boards with big ICs, the little tiny stuff right there. And it basically is just how you can go through, and like I said, this is an example of an evolutionary product line, not an evolutionary product. Is say, okay, you take the best features from the old one and keep crunching it down and getting parts to basically, so how can we make it cheaper and smaller, but also have flexibility, use it for more and more boats, like all these different sizes, all these different applications. So actually this is the design of just basically taking 11 years to get to the kitchen sink from all the million design requirements that everyone starts with as your inventor, right? From the beginning, what if we had a thing that did this? Okay, it took 11 years to get to that point of crunching an enormous, like I said, a room full of hardware down into 3 boxes like that connect to other things.
Was there originally an analog control system?
In fact, that was the one boat I showed you up here. Is the dangerous one was, this was just like from the dark, but I met the guy that did this, I mean, who actually designed the controller for this boat and the designer I work with the boat. And they were proud of it. They go, you don't understand how old this was. And it's this one. Where is it? Where is this thing go? Foil Cat. That was built by Boeing. They worked for Boeing right before they came to Navitec, and their whole careers were based on their pride on getting this thing to work for Boeing. I mean, that was a big deal in the days they did that in like in the early 80s. It was a really big deal with the rudimentary controllers they used and stuff to get it to work. People were stunned that it actually did work. And it basically made their careers. The 2 guys, the one who was the designer of the foils and the control engineer that did that. And what they were able to do made a silk purse out of total solid zero technology. It was pretty impressive. But it was pretty dangerous at that point because it just needed an upgrade. It was a prototype, and they're saying, what do we do with this thing and how do we make it ready for prime time? And so that's what I was saying, is stuff like that. Sometimes things take from the initial idea to something that really works all the time. That's like It's like almost 3 decades of stuff, right, from their lifetime on to mine, on to right now for the Navy. So it's not like everyone invents something and it's done. It kind of keeps moving forward, and it still has value in its past thing, and they just use it and keep adapting it forward. And the funny thing is this thing has a processor that can handle the most complicated, what they call control algorithms on Earth. And what we found out is we're back to the control algorithm fundamental mathematics of like that foil cat, because it doesn't work as well all the time, but it doesn't have the problem of complicated control. Things are what they call the rogue wave or the rogue situation. They all have these, what he calls the adaptive situations, like memorizing what you do. Well, what happens when a new situation comes up? Okay, everyone's killed. The old systems aren't that good and aren't that accurate, but they don't, the answer is they don't care. They work how they work forever.
Yeah.
They work a little bit worse under severe conditions. They don't just go blow up and kill everybody. So they actually there was value in the old days of the really complicated, I don't know, complicated software thing has this outcome of unusual side effects that no one recognizes, and when people's safety is involved, it's a big deal. Anyways, that's as far as I'd like to go, and Tyler's talked about his thing. He wants to talk more about some of the other things he's worked on and for that stuff. Or
I got a quick PowerPoint presentation. You
Oh.
want to unplug that?
oh, okay, you can go.
Oh, yeah.
See a lot of stuff.
All right. Well, my name's Tyler Toth. I'm the sales manager at the Y10 Corporation. We're an electronics manufacturing company, and we're just right down the street in one of these buildings. Like I said before, Vesta's actually one of our customers, so we build all their product for them. We've got another customer right down the street named Pixel Technologies. We've been in business since 1996, serving the aerospace, communications, medical, and let's see, defense industries along the front range. So what we do, the main thing we do is printed circuit board assembly, and yeah, mainly that's surface mount and other state-of-the-art assembly technologies. Producibility engineering, which is a big thing, especially when we're working with a design engineer. It's really nice to have customers who come to us with a new product that they're in development with, because we can say early on, oh, use these type of parts, or do this layout, use this material, because further down the road we're going to know, you know, we can say it's going to save you money in the future, or it'll save you time, or you know, what we try and do is design things so that the manufacturing process is as automated as possible, and you don't need human hands touching it. Additional services, parts sourcing, logistics management. We've got a real nice MRP system, so so we manage a few different inventories, customer inventories, prototyping, box builds, which is just a full product assembly. There are a couple box builds that we've done in the past where we started off just doing the circuit boards. Eventually we built up to where we were doing cable harnesses, putting everything in a box, screwing it together, and doing some functional testing. So, and then, yeah, things like YRCI, you see electromechanical assemblies. So how we do it, the PCB assembly is just automated machinery, pick and place machines, MRP software, process control. Engineering, we've got a few different engineers. John's my right hand man. I usually go to him first, but he can get busy, you know, and and also every engineer has their own skill set, so it kind of depends what you're working on. And yeah, producibility engineering, it's a huge thing, and we're able to do it because we've had experience with a bunch of different assembly processes, a bunch of different materials, parts. Basically, we break it down into a part-by-part analysis, and we consider all sorts of things. Where are the suppliers for each part? Are they reliable? What's the cost of each part? Are these parts going to be available for the next 5 years, next 10 years? What are the price breaks and quantities? So we use all this different information to figure out what the optimal build size is. Should we build these in lots of 100? Should we build it in 1,000 once a year, or smaller or less? Just depending on what the budget of our customers is. And yeah, the main thing is just working with designers to make it so that the assembly process is as automated as possible. But yeah, usually we're able to achieve economies of scale, even if you're doing low volume stuff or relatively low volume. And yeah, just bring production costs to a minimum. And it really just, it's so nice when we're working with John on new projects, because we don't have to say and come into something and be like, why did they design it this way? Now we have to charge you more, and the customer gets upset. They're like, this isn't our budget. So basically, the producibility engineering thing, it just results in lower costs now, lower costs in the future, lower costs over the whole lifespan of development.
Well, if I want to interrupt, this is what they do best, is looking at stuff. Is like, I just had a proposal with them this afternoon. I said, okay, it's going to cost $100 in volumes of 1,000 to this board, just $50. So I'm looking at it because it isn't going to be 100. It's going to be 50, and I was off by 100. And he's absolutely insistent on that. And usually, they've done enough boards where they're kind of right, and they can tell you that's what's going to come out the door when you're in full production. And it's a big difference between saying $100 to a customer or $50. That's just a part of their system. So they get the numbers right. I'll throw out a number up front very accurately, right? So you don't get this. A lot of other people get. We'll have to look at it and do a careful analysis. Not like $50.
Anyways, so
no,
yeah,
it's actually good. I'm just saying that it's working with these guys. It
Yeah.
gives you an answer.
So why manufacture electronics in America? I first just said why manufacture, but I was like, this is only electronics. Of course, all these things, I bolded the big ones. It's safe to share intellectual property. Not saying nobody will steal things, but at least you can go after them in court. When you're in China, you lose all legal recourse, ability. Another big thing is lead time. It's really nice. Our customer right down the road, Pixel Technologies, they actually are in the process of pulling all their production out of China and coming to us, because when he sends something over to China to get built, his money, his inventory is tied up for 6 weeks or more, and that's money that he doesn't have access to. It's not making him money. So we're able to turn things in 3 to 5 days, and it just makes sense, and it saves him money over the long term. So that got me really excited that things are actually coming back sometimes. Another thing, when you're developing products, you can make on-the-fly repairs or revisions during prototyping. You can run down, be like, oh, try this part. If it's not working, you're not going to be able to do that if you're having them built in China. And for the most part, electronics manufacturing has become a commodity, so it's hard to really deviate from the world market price. If they can do it that cheap over there, everybody over here is forced to bring their prices down to compete. It's always going to be cheaper in China or other countries, but not always that much cheaper, and I'll get into more of that. But basically, when it comes down to it, there's a real good argument to build things in America, electronics. But when it comes to low volume and development, to me it's basically a no-brainer. You should do it here. China, a lot of electronics manufacturing is going into Mexico these days. But basically, there's a hindrance on communication. You're dealing with a lot larger lead times. You've got shipping costs, import duties, any equipment or tooling that you send overseas. Don't even think about ever getting it back. We learned that the hard way a couple times. Intellectual property risks, no legal recourse. Oh, I skipped over this. Next shoring, I read this little article in, what is it, Electronics Purchasing Strategies, and they came up with this term next shoring, and the article was all about Foxconn, which is Apple's manufacturer. It's a $120 billion a year manufacturing operation. They're bringing more and more of their operations into America, and the idea is wherever your end product is being sold, put all your manufacturing and developing activities as close to that market as possible. And it makes sense for a variety of reasons, but one of the ones you don't think of is emphasizing proximity to demand and proximity to innovation. And I think that's really applicable to Colorado in particular, because we're kind of in the hub of, you know, the Denver Tech Center, Boulder, and all these other places where there's a bunch of entrepreneurial and technical innovations going on. But yeah, and this is something else the article talked about, total cost of ownership. This is kind of talking to, you know, the mega manufacturers, geopolitical problems, natural disasters, things like that, but it still, you know, applies to anybody who's thinking about going offshore. Yeah, gains by lower cost can be easily offset by just late production and quality issues. The Chinese New Year is something we always plan for months in ahead because they're basically shut down for 4 to 6 weeks, and it's pretty crazy. And then also you have counterfeit components and things like that. But there certainly is a time and a place for offshoring high volume products which involve labor intensive assembly processes. You probably want to go offshore. So, why TAN? We have plenty of experience prototyping and doing development projects. We're established as a high quality, quick, and reliable manufacturer. We do prototype and development jobs for United Launch Alliance, which is the joint venture between Boeing and Lockheed Martin that sends rockets up to space. So they obviously trust us pretty well if they're willing to hook up something we built to a rocket and launch it somewhere. And then, yeah, we also do these types of prototyping jobs for Covidien Surgical Solutions up in Boulder, which they're a huge medical company, and they've actually got manufacturing operations and equipment that far outdoes ours, but their development sector, they come to us because it's so much of a pain to get their own manufacturing people to do something quick, and I'm sure they could do it right, but quick, and it doesn't make sense for them to do it from a cost perspective at such a small volume. So that's why they come to us, which I thought is interesting. We're really lean and mean. You have to be in this industry. We're centrally located. We often just drive over and deliver product ourselves. And we're a smaller size manufacturing company, but I think it kind of works towards our cause in this case because there's higher accountability. We've just learned we have to produce higher quality product and achieve quicker turn times. For the most part, you know, if we're doing our specialty is kind of these small lot, 100 units or less runs, and you know, if you've got a 1% defect in 1,000, that's not too bad. But if you've got one board wrong in 25, then that's a big issue. So I'd like to say our quality is a lot better than our competitors. We always joke about just-in-time manufacturing because literally a lot of jobs we do, we get the parts and we turn around to give them to the guy running the machines, and it's literally just in time. And we have excess capacity. Our machines are capable of building a lot more than we actually do right now because we're doing prototype jobs. Current and past projects, YRCI, we did a lot of producibility engineering, directed the outsourcing of machining and plumbing research and assembly to a couple local professionals. We did the circuit board assembly, obviously, and we basically control, what comes out the door regardless of who built it. We do QA and testing. Goodyear Tire and Rubber, this was before I was working at the company, but we worked alongside their engineers to prototype and debug the run flat tire system back in the day. MapTech, this was a company that sold GPS chart plotters to yachts. There's a couple of different revisions of the units, the chart plotters. In these pictures, you've got a Sea Ray here, which they had a big contract for, and they were putting these in all their yachts for a while. And then you've got like a 80-foot Ferretti there, which eventually the chart plotters got to the point where they not only use like GPS data, but their own sonar. They'd be mapping wherever you went, so you could basically touch a point on the map on the chart plotter, and the boat would drive there. It would know if you're going to run into something or another boat. So it's pretty cool. And then UMG, this was a pretty cool project as well. There was this pretty crazy chip that they were developing, which started off as a 2-foot by 3-foot product. And first of all, we developed the production plan for these guys and all the processes that were used to really bring their costs down. But secondly, we delegated the manufacturing activities from all over the place. There were people in Arizona doing things. There was a shop in the Philippines. There was a shop in China. And basically, it just had to do with who does what best for the least amount of money. What can't we do? What makes sense to go offshore? And it's a pretty cool product. John jokes that the transponders go up lab rats' butts, but they do not. This is like a little transponder that goes under the skin of lab rats, and so it's used to, it's a near field communication type RFID, so basically you scan it and it'll tell you, oh, this is rat number, blah, 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 and it'll have, notes that somebody took, and it can take their temperature, so.
So we could use those on our kids, or?
You could. And we build those. For example, this month we're building 60,000 of those. So we build them on like a 300 up panel, and they get laser cut individually, and then we send them off to, someplace in the Philippines where they do some sort of micro soldering, which is super labor intensive, then put it in a small piece of glass and put epoxy on the end. It just doesn't make sense for us to do that, but certainly the surface mount part of it, you want a lot of control over, because it has to do with yields and stuff like that. So that's a real cool product, and an example of some of the higher volume stuff we've done. I'll show you a quick video here, just so you can see the machines working. Of course, it's loading really slow, but those are the pick and place machines, so they run at like 10,000 components per hour, and it's the same machines they use everywhere in China or this or that. So.
Oh, the components are on those tapes, right?
Yeah, they come in different packages. But yeah, I'm just talking about, in this video, I'm just talking about all the controls we have and processes and machinery. So yeah, basically, over the years, we've seen pretty much everything there is as far as advanced assembly techniques and different types of products, and we're fairly familiar with everything that's out there, normally out there. Any questions?
Do you guys do other types of products besides high-tech electronic? Do you do some very just simple
We do
plastic
loads.
tools?
Oh, plastic tools. It's all going to be electronics assembly related, so not really, you know. We've, you know, with these various projects, we've had to go to 3D printing places or develop, you know, prototype molds and stuff like that. So
You're
we're
looking
familiar.
for a designer, right, for plastic tool products, though, not just, we use them as something we use to the designer of, you know, packaging. That's different than what you're talking about, is the product itself.
The product itself is plastic and
Yeah.
a little bit of metal, but yeah. So
Yeah,
I
I
didn't think
definitely have experience, but it costs. John knows. He'll tell you exactly what it costs to get something injection molded, and I'll tell you how much it is to have a machinist cut it out, and
Yeah.
you pour the mold, mix it yourself, and just pour it. It doesn't
we
come
have
out very good, but it's, you know, it's good enough for some applications.
You know, we do that, and that's what we're saying, the things we're doing is exactly like that for the mechanical prototyping, is that you basically have to get something, you start with what Tyler's talking about, a machinist either cutting aluminum or plastic, yes.
And it's cheap
into
and
the
quick.
shape,
And
yeah, real cheap and quick. You basically, it's there, you hold it and it doesn't work, and then the next stage is like 3D printing and final stages.
Injection.
Injection molding to get the cost down. That's basically, they're a 3-stage thing, each one is more expensive than the other.
Mm-hmm.
It takes way more time.
Gotcha.
You guys,
Thanks.
did you guys see this?
Yeah, we
Oh, cool, cool. Well, thanks for having us, Roger.
Yeah,
We appreciate it.
perfect timing and
And here's my card if you're at all.
yeah, I'll definitely get you guys in our database here.
Yeah.
Are you, with Advanced Assembly, do you competitors you?
Yeah.
Oh,
Yeah, they're definitely a direct competitor. They're one of the biggest ones in the state.
oh, are they?
Yeah, they're probably top 3. So they got a lot of business coming and going. But yeah, they almost specialize in what I'm trying to go for. They're, you know, development, engineer, prototyping stuff. And they've been able to really capitalize on that because they own a bare board shop as well. So you can go to them and sign up to use their free software and create your own CAD files using their software. And normally that kind of stuff is thousands of dollars. So you can create it yourself, and then they'll build it, or they'll build the bare boards, and then they'll get you to populate the boards at their place too. So they got a good
That
business
would be
plan
like
going.
a company that has an electronics engineer and they can,
Yeah,
so it's just a direct link from the
Yeah.
customer to the
yeah, and
manufacturer.
exactly. So
Well, I have a different perspective because I'd worked with them and then started working with White, and it just was their tools were very, very difficult to use, and I felt like, wow, I'm like your employee, trying to get this work done. Like, it wasn't
Yeah.
so simple to get the stuff done as it's.
no,
I was
it's
like,
not.
wow, I'm like, I get assigned a lot of time
So
when
it's
I was
like,
working for
it's like
Navitec.
the Gerber file thing, but it's kind of another layer of.
It's another layer, but it's built. They built on a technology that haven't changed. That's actually DOS based. You literally, I mean, you're literally fishing around with arrows to try to move over a screen. Like, just try to.
They give it
get
to you
parts
for
through.
free.
It's free,
But-
but it was
Yeah.
I had to
They're-
put in this huge
Refined,
amount of
in
time
other words,
to
yeah.
get it manufactured. And I said, well, this
that is great for large